Hello everyone. Today we are going to discuss about types of graphs. So before that we have discussed different terminologies we use in graph data structure and complete graph, strongly connected graph, weakly connected graph, everything. And today we are going to see different types of graphs and how to create adjacency matrix of the graph. So in previous video we have discussed how to create an adjacency matrix for undirected graph. Now we are going to discuss about for directed graph. The same way we have to mention the vertices row and column wise. As we do in matrix, we we represent matrix, we have to write the vertices rows and column wise, and then in directed graph, if there is an edge between A, B, here it is mentioned A to B. So from A to B only, we have to write 1. And B to A, we should not write 1. B to A, there is 0. But just see the previous diagram. This is for undirected graph. B to A also. Here, B to A also we have represented 1. If it is an undirected graph, we can take it as both ways. So we can represent for A to B 1, B to A 1. But whereas for a directed graph, for A to B only, with the direction only we have to mention 1. And likewise B to D it is 1. And B to E there is a path. B to E 1. But not E to B. E to B it is 0. And same way D to E. D to E it is 1 and not E to D. E to D is 0. And D to D it is 1. Self loop. It is 1. D to D. Just look this D. It is self loop, so it is 1. Likewise A to C. A to C it is 1. Because there is a direction indicating. The next is adjacency list. So adjacency matrix, we form a matrix using the vertices row wise as well as column wise. And if there is an edge between two nodes, we represent it by 1, or not, we represent it by 0. And in adjacency list, every vertex of a graph contains list of its adjacent vertices. So here, just see this graph A, B, C, D. Here we represent this by linked list representation A, B, C, D. So from A there is a path for B. So we are representing it as a adjacent list from A to B, and from A to B and A to C. So A to B, likewise from A is connected with B, A is connected with C, and B is connected with D, B is connected with E, right? So D and E, and likewise C is connected with D alone, so D, and D is connected with A, then E, then D, self loop, so D, okay, and E is not at all, from E there is no edges coming out, right? So we represent this as null, so there is no connection for E. So this way we represent adjacency matrix, adjacency list. So two type we can represent for graph. One is adjacency matrix and adjacency list. So this is adjacency matrix for the weighted graph. Weighted means on the edges you will be having a value. A value is assigned for the edges or the link. Okay. So if there is a connection and the value is represented, you have to write that value in the matrix. So here 1 to 0. Okay, 1 to 0. Just see vertex 1 to 0. The value is 2. So I am representing it as 2. And from 1 to 2, the value is 15. So 1 to 2. 1 to 2 means here. 1 to 2, the value is 15. So I am representing it as 15. So likewise, for weighted graphs, the weights will be represented on the matrix. Thank you.